Welcome, everybody. So today we're going to talk about MiniCube. The title of the talk is How You Start MiniCube. It's MiniCube Start. We will have a deep dive on Thursday that's going to call MiniCube Status. All right, so let's see why. OK, it does work. Excellent. So who we are. I'm Bálint Pató. I work for Google for a year and a half now. Recently started working in MiniCube and Kubernetes. I'm part of the Google Container Tools team, which is working on local developer experience tools like MiniCube, Scaffold, Canico, and others.
Mm-hmm. And my name is Thomas Strömberg, and I just joined the team I guess 3 months ago, and then joined as a MiniCube maintainer about 2 months ago. So if it sounds like I have no idea what I'm talking about, there's an inkling of truth there. So
same here. All right. So MiniCube is not just us. Obviously, we just started 3 months ago to contribute and maintain, help with the maintenance. It's 390 contributors who worked on this code base for 2.5 years since April 2016. Later about this slide, which looks super cool, you'll see how I created it the non-easy way. So the goals of this talk would be to give you some idea how to get started with MiniCube, decide if you will be able to decide whether MiniCube fits your use case or not. You will hopefully understand where MiniCube came from and where MiniCube is heading. And if this all sounds good, you're interested deeper, you want to contribute, you want to understand the architectural subtleties and do some debugging with us, then come to the deep dive session on Thursday. So we'll do some introduction and some demos, talk about a little bit of internals, landscape, and then some strengths and weaknesses of the tool.
So first, I'm going to apologize for the bad artwork. I had some other slides in here, like a shark with a laser beam on his head, but I got called out by my manager for that. There's some copyright violations in your presentation, so I did the best I could. Anyways, so I like to think of Kubernetes as enabling all of us to be intrepid space explorers, colonizing distant worlds full of computing resources in a sane and sustainable fashion. However, being deployed to a distant world is kind of an expensive and dangerous and complex affair. And sometimes you need something a little lighter weight just to test an idea or develop locally. So when we're developing Kubernetes apps, it really helps to have an environment where failure is cheap and fast. We don't want your failures to cost you GCE resources, for instances. So that's basically where MiniCube comes in. It's a place where quick and fun experimentation is really the name of the game. And this kind of reminded me of another game, Kerbal Space Program. Raise your hand if you've ever played Kerbal Space Program. All right, there's actually more of you than I was imagining. So anyways, for those of you who haven't played Kerbal Space Program, it's a game where you design and assemble fully functional rockets in an environment where you have actually a pretty decent physics engine that is accurately simulates whether or not your rocket that you've assembled is actually going to go fly to the moon or not. So MiniCube is kind of similar in that it's a high-fidelity simulation, and you get to pick the different parts. You get to pick your container runtimes. You get to pick your Kubernetes version. Go to the next slide. So any XKCD fans out there? All right, so this is kind of ripped off of one of his more famous cartoons. In fact, there's actually an XKCD font that I used because my own handwriting is illegible. So anyways, so what's involved in setting up a local Kubernetes environment? How does MiniCube do it effectively? Well, the first stage is a machine driver. Here I've selected KVM2. This is basically how are you going to provision your machine? MiniCube runs normally by provisioning a VM locally. and we have a vast assortment of drivers to select from. I picked KVM2 because, at least on Linux, it's one of the faster options. I can fire up a local Kubernetes in about 2 minutes with this configuration. So the next stage is you've got the bootstrapper. And in this case, it's kubeadm. kubeadm, any of you have used kubeadm yet? All right, a handful. It's awesome. It is actually greatly simplified MiniCube. Before, we used to use something called local kube, which was basically like it vendored in a bunch of Kubernetes components and ran it all as a single process. Now that kubeadm exists, we can actually set up a proper Kubernetes cluster. We've got container runtimes. Here I selected Cryo. There's also a variety of things. We've got Kubernetes itself as kind of the orbiter. We've got add-ons. Here I selected Ingress, and then your app is kind of hiding there in the very top of the stack. And so, yeah, that's basically what MiniCube does in a nutshell, is assemble all these parts. So now it's time for a demo.
So let's see a little bit of demo. Hope that the demo gods are with us. So I have MiniCube running in the background. So I started it up with a very simple command, MiniCube start.
Yeah.
Actually, I passed in VM driver hypercat because that's what I decided to use for the demo. And then some logging stuff. MiniCube start takes a lot of arguments, actually. So you can set up CPU size of the virtual machine and disk size and memory and other kind of things. Most of the configuration goes in as an argument to MiniCube start. So MiniCube is running, and then here I have a command that is constantly watching the pods. So I have basically kubectl get pod in all namespaces. And then here I have the same for the services. So you can see that the system is up and running, so Kubernetes is healthy. And so let's try to deploy something. So, oh yeah, another thing that I'm going to show is MiniCube tunnel. So MiniCube tunnel will create a network route into the service IP range inside the VM.
Yeah, and MiniCube tunnel is actually something we just released as a way to enable load balancer emulation. So.
Exactly. So when I create now run nginx a pod, and then I'm going to expose that. So the pod showed up here. It is creating, and it's running. And then now I'm going to expose it. Expose deployment nginx on port 80 and of type load balancer. So a load balancer type service is created. So we're going to see it here. The nginx service popped up. And you can see that the external IP was set. So that's what MiniCube tunnel, that MiniCube tunnel that basically replaces the external IP with the IP of the service. So if I now go to my browser and, okay, that was the room number where we are. Let's see where I am, sorry. So that's the IP address, and let's go there. nginx, up and running, excellent. So let's do another trick. So a bit more involved deployment. I created this sample app called Contribol. So this is a hard way to actually create that slide that I was referring to with the faces. So I have a backend which was written in Go that actually goes to GitHub and then goes through the contributors list for MiniCube and then returns in a JSON array all the contributors. And then the front end is a React JS app that refers to this contributors service. In the back end, it's using the DNS resolution inside the cluster. So I'm going to deploy this application now with Scaffold. So Scaffold is another tool that we are developing. It is enabling locally to develop in a continuous way. So if I just say scaffold dev, it's going to build both of these services. So I have these two artifacts here, the contributors and the contributable UI. So these are defined by two Docker files. Each of them have their own Docker files. And so Scaffold builds them. And then after the building, it's going to deploy them to our Kubernetes cluster. So because the current kube CTL context is pointing to MiniCube, it is going to deploy it to MiniCube. Now, another thing that Scaffold is doing here is we are sharing so MiniCube has a Docker daemon running inside the VM itself. And so Scaffold knows about that. And then instead of pushing to a registry, it just builds the image on this shared Docker daemon. So it's actually super fast to publish it to the cluster. So it's up and running now. And I will open this up. Let's see what's happening here. So we can see that there are two pods, the front-end pod and the SVC contributors pod. And then there's the front-end service, which is of type load balancer as well. So I can go to this cluster IP, and fingers crossed, this should work. OK, wall of contributors for MiniCube. So it's coming soon. That's how fast the Wi-Fi is. So just one more fun thing to show with Scaffold. So you can see that the app.js file is set up as syncable. So when I change this file and say, hello, KubeCon, then Scaffold will sync it directly into the pod. And voila, it reloaded. So this is what we aim for with this team to make local development productive and fast.
So when you say sync into the pod, you mean it built another built-in image again, or it's syncing like code into a running?
So the question was whether we were what does it mean when I sync it to a pod, whether it builds the image or we sync into the pod itself directly. So there are two modes. If I change a file that is not part of the syncable, it's not marked as syncable. Like if I change this package JSON, I'm just going to put a new line here, then it is actually going to rebuild the Docker image. But if it's passed in as syncable, then Scaffold will actually kubectl CP it into the pod to the given path.
And one alternative to this approach is that you can actually do mounts within MiniCube to get access to the host file system. But this is way cooler.
All right. So April 2016, I don't know if anybody used Kubernetes back then.
Anyone from
Hands
April
up?
2016?
Yeah, me neither.
All right. So what were you doing to test Kubernetes back then? Or just deploying?
So people were talking about we needed to have a local cluster experience. This proposal went in, and a couple of months later, Dan Lawrence, who is our teammate, an ex-manager, he implemented it, the first versions of MiniCube, and by June, I think 0.2 was already published on the Kubernetes website. So that's a little bit of a historical background. The design goals were to have a speedy local development experience with a single command setup and teardown, fit all the Kubernetes features that make sense, have a unified user experience across the major operating systems, introduce minimal dependencies, and become the de facto local Kubernetes solution. So why MiniCube? Why do people choose MiniCube? So we ran a survey a couple of months ago.
Yes.
By the way,
Please fill it out.
Please fill it out as well.
The more the merrier.
It's constantly running. So 62% of the people use it for local development. Some people use it for testing. And education is a big use case as well. So learning and teaching MiniCube.
Yeah. For many people, MiniCube is their first experience with Kubernetes, and we would like to optimize for that.
So what are the features in Kubernetes that fit into a single node local experience? The answer is most of it, a lot of it. So some of them come in as emulated features. For example, the load balancer with MiniCube Tunnel that I just demonstrated. So that's not a real load balancer. Some of them come as add-ons. So Ingress and Dashboard, you can use them as add-ons. I'm going to talk about that in a second. Secrets, config maps, DNS, you use them as usual in your cluster. So you can use the same scripts as you would use in a real Kubernetes cluster. Talking about add-ons, we have a bunch of them. This is kind of like a marketplace inside MiniCube that you can contribute to as well and check out for adding interesting features. For example, gvisor support. Gvisor is Google developed open source sandboxing technology to run untrusted workloads. So we recently added gvisor support into MiniCube as an add-on. You can run a registry, add GPU support on Linux for a pass-through GPU, so you can run machine learning workloads, and so on and so forth. All right, MiniCube internals.
All right. So I'm going to talk a little bit more about MiniCube internals. So one of the things that makes MiniCube MiniCube is this confusing support matrix. So we support a lot of options. Some of them are better supported than others. We haven't formally specified on our website which ones we consider gold or silver or bronze, but we'll probably publish this soon afterwards. It's worth noting there are actually more hypervisors than I could fit in the row here. But I put the most common ones anyways. So yeah, the gold ones are the ones that we continuously test. They're part of our CI. The silver ones are the ones that we should be testing in our continuous environment, but are not yet for whatever reason. And the bronze ones are your mileage may vary. If you are going to try that, you may have to submit PRs to make it fully work or wander through deep caverns of no documentation. So to get there. So we would also like to better support those. I put local cube in here just as a shout out to show where it actually fell into the stack here. But it is gone. So one thing you'll note is that we are not currently tracked on the current version of Kubernetes. We really should be. And we tried really hard. We were actually at v1.12 for a couple of days, and then we backed it out because it was not giving the best app developer experience due to the slowness of deployment. So we went back to the drawing board and reverted back to 1.10 as the default. You can switch to any of these versions, though. And we hope to follow it up with 1.13 as the default by the end of the year. So yeah. So to make this matrix possible, we have to have ridiculously good continuous integration testing. And so most of the investment this last quarter for us as a team has been investing in our CI. So you can see kind of in the beginning, early November, this is showing that 80% of the time that we were testing from head, at least one test would fail. And that made approving PRs really difficult. So in fact, we actually, I basically informally said, I'm not looking at any PRs until we get our integration testing straightened out. So you can see we started to trend downwards, and we got to the 5% range that I was comfortable with, and then we started merging again. We started adding tests for container D, so that bumped it up a little bit. We found flakiness issues. And then we merged gvisor, and actually it was gvisor and v1.12 as default at the same time. And things went horribly wrong. And that's why I actually switched v1.12 off by default. There was a little conflict in the config files. And it was also timing out a lot.
It is challenging to run integration tests with virtualization and a whole cluster in it with applications, with distributed setup. So it was very important to actually implement metrics and tools around it to track the flakiness. And hopefully we'll be under 5% soon.
Yeah, we're going to continue to chase this one down. And as you can tell, we've started merging PRs again. So what did we do in 2018? So we added the load balancer emulation that you saw demoed there. We improved our container runtime support, added the experimental GPU support, improved mount, improved reliability. We switched the upstream for our machine drivers from Docker machine to the machine drivers org, which is maintained by the folks at Red Hat. So they work on MiniShift, which is a fork of MiniCube. And so this is where we did as a collaboration so that we could share more code. So we added gvisor for untrusted workloads, retired local cube, and we added v1.12 support, but not the default at the moment. So we're going to explore a little bit under the hood here. All right. Which window is OK? Sorry, I'm usually a Dvorak typer, and so I am like a fish out of water at the moment. Mind if I expand this out?
Yeah.
All right. So MiniCube help. It actually is helpful. So we have a bunch of commands. The one that I was going to kind of focus on here is MiniCube SSH to kind of show some of the internals of how this thing works. So usually you don't need to go mucking about and SSHing in. It's not really the intent, but it is often useful for debugging. So you can see that so this is a build root based VM and running in HyperKit in this environment. So if we look for the kubelet, we will see this is a normal Kubernetes kubelet deployed with kubeadm. Not too much special with it, other than we actually allow this kubelet to be schedulable. Typically, the master kubelet is not designed to be schedulable, but we're single node, so we did that. You can see there's API server. You can look at the logs for the various functions here. Not too terribly exciting on that aspect. So you can also look at the MiniCube Dashboard, just like in a regular Kubernetes cluster. So this actually had we had an interesting CVE around this in a couple of versions ago, because the way that we were deploying this. Basically, if you were on a VM that had a predictable IP, this was on a predictable port, and somebody could do some interesting attacks to get around the fact that it was just bound to your local IPs. So
Thomas fixed it.
yeah, I fixed it. I changed to using kubectl proxy. So that's how it works nowadays. Let's see. So we're running. This one it's running Docker, right?
Yes.
All right. So we can say MiniCube Docker env. So
this is the shared. This is how Scaffold uses the Docker daemon inside MiniCube as well. So you see Docker env actually exports the commands for pointing the Docker client to the endpoint of the Docker daemon.
So yeah, we can talk directly to it. So that's how some of the magic works. Let's see, wizard. And I didn't share it, or show it, but there's also a a toolbox command that you can run if you want to switch into a Fedora distribution container for doing some more advanced debugging if your favorite tools are not available. You can just DNF them. There are some concerns around disk space usage at the moment, but anyways. Landscape.
Landscape. So I don't know if you've seen this, but there's a bunch of installers out there for Kubernetes. So it gets scary. So I wanted to put in a couple of slides around trying to explain it for ourselves as well, and maybe you can take away some ideas as well around and to place MiniCube in the landscape. So some of these projects have overlapping focuses, overlapping responsibilities, but some of them are used for different things. So MicroK8s is one project from Canonical that is very similar in terms of goals to MiniCube. It is for local development. It's a single command startup. It's available as a snap package. Isolation is provided by LXC and not VMs. So it is great. It's Linux only. So that's one great local development tool. Docker for desktop started to add Kubernetes in their VM, so you can use that. Actually, I might be able to show that here just for a quick show. So yeah, there's Kubernetes there. So Docker for Mac and Docker for Windows has this. It is for local development. It's a little bit less flexible as MiniCube. It's Docker only backend, and if you deploy more than one services of type load balancer, then the second one and the ones after will be pending the external IP because they are tying it to a local host, the IP address. So it's a little bit different, but it's also very convenient to use and get started with. Kind is a recent project in the SIG cluster lifecycle group. It stands for Kubernetes in Docker. So its focus is end-to-end testing of Kubernetes itself. It's Docker-based, so it solves spinning up a cluster given one requirement, one dependency, and that's the Docker daemon. So it spins up all the components as Docker containers, and then everything is running in Docker containers. So there's no more isolation than that, or no other layers. So it's very lightweight. It is useful for local development as well, but it's mostly very useful if you want to actually develop Kubernetes. Yeah. Minishift is a MiniCube fork, but it's focusing on OpenShift, so it spins up an actual OpenShift cluster. We work very closely with the OpenShift guys on MiniCube itself. So kubeadmin, kops, and kubespray are other ways to bootstrap Kubernetes. These are actually driving real Kubernetes installations. Kubeadmin is the building block. That's where everything consolidates. So we are using kubeadmin as well under the hood. Kops drives the full lifecycle of your cluster, so including infrastructure management as well. Kubespray is very similar to kops, but it's Ansible based. All right.
All right. So I'm going to talk a little bit about some MiniCube superpowers and a little bit of kryptonite.
5 minutes left.
Yes. OK. So as we demonstrated earlier, great for faster iterative development. It democratizes the Kubernetes development experience. It's free. It's open source. It's supposed to be dead easy to use. No rocket science or YAML required.
Despite the rocket-related graphics.
And it's running real Kubernetes, cross-platform, easy to extend. It's basically designed to work for everyone. So a little bit of the kryptonite. Where does MiniCube fall flat? Proxies, VPNs, and firewalls kind of get in the way. Oftentimes, it gets in the way between the host and the hypervisor. That's a common thing we see. For instance, corporate VPNs or corporate firewalls may, I guess the VPNs will route like 10.0.0.0/8, and that's what we use to talk to the VM locally. Also, connectivity from within a guest VM to the outside world might be hurt, and it works badly there too. So connectivity issues in general. We actually see this a lot in China, for instance. China can't access GCR.io and many other sites. So MiniCube works badly by default there because a lot of the default images that people use come from there, like the pause container image. Production use. We do not recommend MiniCube for production. Contrary to what we have seen some people do. Cloudflare. They have a really cool blog post on using that. So VM driver equals none. So you can actually tell MiniCube to pretend I'm already in a VM and just roll Kubernetes out locally. This makes certain assumptions in that it'll actually overwrite system binaries because it is running kubeadm and can overwrite some config files. So don't run it on your desktop. Some people do. We'd actually like to have a better answer for this story later. Performance-sensitive tasks. Well, it's in a VM. Large resource footprints. So you can make this work. I guess I forgot to put the number of CPUs. But anyways, infinite CPUs. So like if you want to run Istio, for instance, you're going to have to tell it to provision a larger VM. So for 2019, what would we like to do in MiniCube? Well, right now we've got MiniCube's really flexible, but it isn't user-friendly for everyone yet. And because this is the first experience many people have with Kubernetes, we should do better. So we would like to do a single-step install, clear end-user documentation, help wanted. Please talk to me afterwards if you want help in docs. We'd like to stop asking people to delete the MiniCube folder when they make certain changes. That's kind of absurd. We'd like to make it easy to debug. When things go wrong, it can be confusing right now. We'd like it to be more inclusive. We'd like to increase the diversity of the contributors and maintainers. For instance, some of our largest markets, we don't have active maintainers from. That we can do better on. We'd like to make it offline friendly and have a better VM-free experience. If you noticed why we didn't run MiniCube Start here, by the way, in the beginning of the demo, it's because it works badly when there's bad connectivity, like at a conference. And so we would like to make it for all the people in third world countries or at conventions to be able to run MiniCube. You want to talk? Sorry.
Oh yeah, the open source governance is another thing that we want to work on next year. So currently it's mostly us and the MiniShift guys who contribute. So there are who are maintainers who can approve pull requests. So we want to increase the circle of maintainers, get more people involved, more companies involved. So that the project itself is self-sustaining and can run long. We strongly believe that MiniCube is an important piece of the puzzle in the ecosystem, and it should stay free and live long and prosper. So we want to invest in a better governance structure around it.
All right. So now for questions. We encourage you to try out MiniCube if you haven't already. There are some places where you can discuss MiniCube. As we mentioned, there is a survey that we would love to get people to fill out so we can know why people use MiniCube and what we can do better.
Hey, thanks for the talk. I really like MiniCube. I use MiniShift as well. Administering the cluster, like setting the API server configuration, and that seems a bit difficult.
Yes.
Have you done anything to try and improve that?
No, we haven't. But one of the things that we would like to do as a pre-flight check is to verify configuration sanity so that we can give you a really, really quick feedback to let you know, is this going to work? Because right now, if the API server crashes because the config's bad, you basically end up waiting like 20 minutes, and then you get back confusing error messages. You're you're right here, so I'll be lazy.
Hi. I've been using MiniCube to test the service mesh. But every time I do it and I stop and delete and start again, MiniCube doesn't work. It just hangs. I don't see is there any way to debug that.
You can come to our deep dive session, or you can talk to me right after this, and
Okay, sure.
I can help you work out your support issue.
Beginning to go on the Kubernetes journey for a number of companies. In Mush, we've got the graph where you've recently launched the load balancer through the tunnel. Do you have a list of, or you're in the delta, so what isn't available or what MiniCube cannot do in the current context? So what are the known pitfalls that we would have to run it on a production cluster, or like you're on an environmental cluster or proper Kubernetes cluster per se?
We should build that list, but one of the trivial things is you won't be able to test multi-node things. So because it's a single node setup, node-related logic and failover testing is not going to be available. The load balancer itself is emulated, so it will give the same IP as the cluster IP of the service. So that's a little bit different in that sense, but it's similar enough. I think that we should document that and then have a clear delta. But most of the things are pretty much the same.
Okay, so using something like Envoy wouldn't be particularly, like that's a current capability that could be deployed with MiniCube at the moment?
I don't know. I haven't experimented with that. So
I haven't tried Envoy either, but I don't see why it shouldn't.
Yeah.
Okay, brilliant.
Theoretically, it should. So you can deploy Istio, for example, and whole Knative into MiniCube. So I'm pretty sure that Envoy can.
Yeah, if Envoy doesn't work, that's an issue, and we should solve that.
Yeah, sort of as a follow-up to that, what's preventing MiniCube from being able to deploy multi-node?
Lack of pull requests.
Well, also, it's a philosophical question that came up a lot of times as we were digging into the history. So there's a long conversation around how it could be implemented. In the end, yeah, I think that's an open question whether we want to implement it or not.
It's an open discussion. It's something that we have seen people ask for, but no one's actually told us why they want it. Oh, I would love to hear it.
As a CI/CD developer, I'd love to not have to wait for Jenkins to build and deploy everything to a Kubernetes cluster in our development environment.
Right.
So having it locally to test things like blue-green, canary, the different failover scenarios would be awesome.
Yep.
Because right now it's a pain in the butt.
Yep. Thank you.
Thank you.
All right. I think that we are out of time.
Well, we'll take one last question. Maybe.
All right.
First of all, thanks for all the work you guys do on MiniCube. I have kind of an interesting use case, and I'd like to know if MiniCube is right for me. I have some services that I run at home, and I want to run all the time. I also want to learn Kubernetes and be able to upgrade it. Is MiniCube the right tool for me?
It might be a good way to get started, but you might end up graduating to running just kubeadm yourself eventually on bare metal. But I don't see why not as a way to get started.
Okay, thanks.
Thank you.
Thank you, everyone.